Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. In this video, I would like to discuss about Gauss elimination with partial pivoting. In previous video, we already discussed how to solve our system of linear equation or matrix by using Gauss elimination method. Somehow, there are pitfalls in that method. So, the two pitfalls involved in knife Gauss elimination are the first one, division by zero, where this may occur in forward elimination and also backward substitution. And the second one, the method can give large amount of error. Here are the example of pitfalls that caused by Gauss elimination method. So the first pitfall, division by zero. This is our system of linear equation and we transform this equation into our matrix Ax is equal to B. Then we combine matrix A and B and we want to make matrix A, this element into 0, become upper triangular matrix. So the formula for the first method, for the first step for row elimination, R2 plus minus 2 divided by 0 multiply with R1. From here, we can see the bottom part of our fraction is equal to 0. So what happens if we divide by 0? So we cannot do the calculation. Okay, the next pitfall is large round of error. This is our matrix, and if we solve by using exact solution, our x is equal to 1, y equal to 1, and z equal to 1. But when we solve by using Gauss elimination method, that is an approximate solution, this is our answer. X is equal to 0.625, while y equal to 1.5, and z is equal to 0.9995. We can see value for x and value for y is very far from our true solution. The simplest remedy to reduce the run of error is to increase the number of significant figures in the computation. However, it would contribute to the computational effort and large memory are required for the storage. Then the technique of pivoting can be used to avoid both division by zero and also minimize run of error. Pivoting involves the rearrangement of the equations so that the pivot element has the largest magnitude compared to other elements in that similar column. This technique can be incorporated into knife Gauss elimination method and it is frequently known as Gauss elimination with partial pivoting. It involves the same step as knife Gauss elimination method, that is forward elimination and backward substitution, with an additional task that is we must ensure our pivot element must have the largest magnitude before each of the n-1 steps of forward elimination is performed. So, for better understanding, let's try one example. Solve the following equations by using Gauss elimination method with partial pivoting. So, firstly, let's transform our equation into matrix form. So, we will have 0.3, 0.52, and 1, 0.5, 1, 1.9, 0.1, 0.3, 0.5 with x1, x2, x3 equal to negative 0.01, 0.67, and negative 0.44. Then, we transform our matrix into our augmented matrix. Augmented matrix is combination matrix A and matrix B. So we combine, so we have 0.3, negative 0.52 and 1, 0.5, 1, 1.9, 0.1, 0.3, 0.5. combined with matrix B, we have minus 0.01, 0.67, and minus 0.44. So this is our matrix. We have 0.3, 0.52, 1, 0.5, 1, 1.9, 0.1, 0.3, 0.5, matrix B, negative 0.01, 0.67, and negative 0.4. Okay, for the first step, before we can do the forward elimination, the question asks us to solve by using partial pivoting. Gauss elimination with partial pivoting. That means we need to make sure our pivot element must have the largest magnitude. So, from this matrix, we compare for the first column. We compare between 0.3, 0.5, and 0.1. Which one is the largest value? So the largest value is 0.5. So we need to change the row. So the formula, we change R2 with R1. So our matrix become 0.5, 1, 1.9, 0.67, 0.3, 0.52, 1, negative 0.01, 0.1, 0.3, 0.5, minus 0.44. So from here, we can see our pivot element, this is pivot element, become the largest value from 0.3 and 0.1. Now we just continue with forward elimination, where the formula is R2 plus minus 0.3 divided by 0.5 multiply with R1. How about for the R3? R3 plus minus 0.1 divided by 0.5 multiply with R1. So our matrix become 0.5, 1, 1.9, 0, negative 0.08, negative 0.14, 0, 0.1, 0.12, and this side becomes 0.67, negative 0.412, negative 0.574. Okay, we can see from here the value for A21 and A31 already 0. The next step, we are going to make value for A32 equal to 0, so that we will have upper triangular matrix. Okay, now value for A21 and A31 already 0. The next step, we are going to make A32 is equal to 0. So before we continue with our forward elimination, let's check the pivot element. Okay, whether our pivot element have the largest magnitude or not. So now let's compare between minus 0.08 and 0.1. Which one have the largest value? Of course, the largest value is 0.1. So we need to change our row. So the formula is we change row 3 and also row 2. What happened to our row 1? Okay, row 1 remain because we are not going to touch, we are not going to do anything with our row 1. Okay, so our matrix become 0.5, 1, 1.9. Okay, we change row 2 with row 2, row 1, row 3 with row 2. So 0, 0.1, 0.12, 0 minus 0.08 minus 0.14, and the other side we have 0.67 minus 0.574 and negative 0.412. So now our pivot element, okay, which is 0.1, okay, already have the largest magnitude between these two rows. So now we can continue with our forward elimination. So the formula is R3 plus minus 0.08 divided by 0.1 multiply with R2. So do the calculation. So I will have 0.5, 1, 1.9, 0, 0.1, 0.12, 0, 0, negative 0.044. And the other side we have 0.67, negative 0.574, and negative 0.8712. Now from here, our matrix A already have in upper triangular form. This one. Okay, here this is already in upper triangular form. Okay, since we already have our metric in upper triangular, so now we can do the backward substitution to find the value for x1, x2, and x3. So for backward substitution, okay, so we start with the x3 first. So from here, x3 is equal to negative 0.8712 divided by negative 0.044. So we will have negative 14.9. Then we continue with x2, we will have negative 29.5. And the last one, x1 is equal to 19.8. For the next example, so this is our matrix. So let's write in our augmented matrix. So we have 1, 4, 10, negative 2, 3, 1, 0.5, 0.1, negative 2. And the other side we have 0.1, 11, and 2. So before we do the forward elimination, so we need to check, make sure our pivot element must have the largest magnitude. So let's check for the first column. So we have 1, negative 2, and 0.5. So between these three values, which one have the largest magnitude? Okay, so for this case, the largest magnitude is 2, negative 2 here. Although we have negative here, but we take the largest magnitude. Magnitude means always positive. So this one become the largest. So we need to change our row. So row 2 change with row 1. So you will have negative 2, 3, 1, 11, 1, 4, 10, 0.1, 0.5, 0.1, negative 2, and 2. Okay, so please be careful. Okay, although we have negative here, but since we want the largest magnitude, that's mean the value must be always positive. So we just can ignore the negative. We just take the value. So between 1 and 2, of course, 2 is is bigger than 1. So we need to change the row. So our pivot element become the largest compared to 1 and 0.5. Then we can continue with our elimination process. So you can continue by yourself. All the best. Hope everybody can understand between Gauss elimination method and also Gauss elimination method with partial pivoting. So thank you guys.